Greetings everyone. Here's a progress report on my tower-mounted 10 GHz narrowband system. I was waiting for some material to arrive by mail, and we had a postal strike here in Canada, so I had to slow down and did keep on working a little bit. You saw that I created that standalone 10 GHz receiver that I will be using to monitor this transmitter. So I was not totally stalled, but now I got the parts I needed. I can move forward and plan on integrating these. So the two boards I was waiting is the Transverter board and the local oscillator tripler, the LO tripler board. And now that I have them, I can start to put everything together. So I think I found the enclosure I'm going to be using for these functions. And it's this enclosure here that has grooves. It's an extruded aluminum box. And with these grooves, it's normally designed to slide a PCB inside. But I decided to use an aluminum plate of the right thickness. It's a scrap recovered. And if we slide it down in the right location, here at the bottom, almost at the bottom, we can definitely use this sliding system here. So we can work on this plate, and when everything is done, we insert it in the box. It should fit. The tight dimension will be the height. We'll see. And I'll show you why. Okay, so the intent is to mount, like I said, everything here. Now there's one thing that is important, and it's to try to avoid too much noise coupling from this synthesizer board. So the plan is to actually mount these face down, of course with some height, with some spacers, and this face up like you see it here. Now, another thing I want to do is something I did not do in the previous system because they were separate boxes, is to literally solder them together. Line up the output track of the tripler into the input LO signal of this board. The tracks are almost of the same thickness. There is a bit of excess material on the edge of both boards, which I'm going to have to file off. Bring the two together and solder directly, or use a coupling capacitor. I'm not sure. I'll probably just solder, and then solder the grounds on both sides, and the other side is going to be a continuous fillet of solder. And it will make it a single unit. There are pros and cons in doing this. Of course, I will not be able to test this board individually once I put them together. So we'll see. Do I go temporarily with a connector to try it out, and then when it's done, remove the connector, desolder, and then try to solder? I think it will leave a messy job. I'll probably just solder everything together. I've tried it already on the previous system, and I know it works. Okay, so should be okay. So doing so and then flipping over like this, it will leave us a bit of room. If you look at the enclosure size, if I line up this corner here, it will leave us some room here for connecting the synthesizer internally with a short piece of SMA coaxial cable to the input of the tripler that will fit inside the box. It will also leave me some room if I want to fit some more electronics inside here. I was considering maybe putting the 144 megahertz attenuator inside this box as well. Not sure whether I'm going to do it though. Still debating whether I should do this. It will be pretty tight in space, but it would integrate the system even more. Now, the critical thing is the height, the overall height, like I mentioned. And if we put the pipe cap like this, just for example, and I slide this whole thing down in the groove, again, it's upside down, there we go. And I look at the space I have left. There is some space. It's not like there's no space. Now the board is flat on the surface, so I will need to raise this thing, and if I raise it, how much room I have left is the problem, because remember, I'll have a tuning screw here on top. So it doesn't have to be very long. I may even cut the tuning screw so that it barely protrudes, but there's a nut that's soldered, so it's not going to be obvious. The worst case that may happen is that I will not insert the screw in the pipe cap. First, mount and slide the whole thing inside, drill some holes here, and then screw down the screws, the tuning screws into the pipe caps from the outside. And then when everything is done, I can seal with some aluminum tape if I really want to. But it would create some small holes, small tuning holes that I would use. So I have a plan B, and that's what it is. But hopefully everything will fit. I have a few of these enclosures, so why not using them? Extruded aluminum is not necessarily cheap. A box like this would probably go for around $20. So I said, hey, I might as well use what I have. I don't have any end plates, but they're easy to make with some thin aluminum plates, and there's already fillets in the four corners for some screws. One additional concern I have is the proximity of this aluminum surface to the circuit. So depending on how high I put this thing from the plate, and remember, I will not be able to put it very high because of the pipe caps. Depending on how high it is, there may or may not be some coupling from one port to the next. It could even induce oscillation. I doubt. MMICs are not easy to make them oscillate, but it's not an impossibility. So worst case, I could always replace this plate with a PCB plate, a bare PCB without any copper. This is something I may consider as well. It will not be as rigid as this guy, but it will indeed raise the surface somewhat. And it's an interesting avenue. I may think about it if I have issues with some oscillations or coupling. So the isolation between stages, if I see that some of the signals are not attenuated, like the harmonics, like they should be with the pipe cap filters, then I may decide to replace this thing with a PCB. The reason why I want to keep it is it does provide some grounding everywhere on the surface. So it helps with grounding the different PCBs, which is something I wouldn't get if I use a PCB, a bare PCB without copper. So there you go. That's the plan for the next few weeks, working on this. And we'll have to think about where I mount the low noise amplifier. Do I mount it at the feed point, or do I mount it inside the large enclosure that will contain all of this? It will be a plastic enclosure. Of course, the best RF scenario is to mount it at the feed point, but if I do so, I'll have to have also the coaxial switch at the feed point. So both LNA and coaxial switch, and have two transmission lines coming from the feed point into the large enclosure. It's more of a mechanical issue than an RF issue. And another aspect I've started to work on is controlling all of this. So in a future video, I'll show you exactly the plan I have. I'll need an intelligent controller inside the large enclosure up on the tower, and an intelligent controller in the shack as well. And both will communicate using an RS-485 data link. And this is how I'm going to control everything, including the rig in the shack. So everything is going to be sequenced using Raspberry Pi Picos. One on top at the tower and one in the shack. That's what the plan is. I've already started exploring things. And also, remember, I need to show you the linear actuator, the system to steer the dish. This is also integrated into the smart controller, so I will show you that in the future. So stick around, I'm far from being done. My objective is to be ready in the summer. Until then, 7-3.